It usually starts late at night. A developer checks their inbox, opens a routine cloud hosting update, and finds a bill that defies basic math. Developers' logs on Hacker News document the scale of the damage. One user reported a $638 bill in 6 weeks while using the Cursor code editor. Another developer pointed their API key at a billing-enabled project and triggered a $127 charge from Google's Gemini in exactly 7 days, despite virtually zero active usage. In almost every instance, these developers had intentionally selected a budget AI model. They audited the pricing pages and picked the cheapest available option to keep their operational costs low. Selecting the model with the lowest sticker price is leading to massive budget overruns. The per-token rate on the pricing page is no longer translating to the final invoice. This chart compares listed API prices. On the left, Google's Gemini 3 Flash sits at $3.50 per million tokens. On the right, Anthropic's Claude Opus demands $30 for that same volume. On paper, Claude is 9 times more expensive. But a March 2026 peer-reviewed paper from researchers at Stanford, UC Berkeley, Carnegie Mellon, and Microsoft Research tested that assumption. They ran 11,872 queries across 8 different models and 9 distinct benchmarks to see what happens when the code actually runs. They identified a price reversal phenomenon. In actual execution, the model with the lower listed price frequently ends up costing more than the premium option. This occurred in 21.8. When you pull apart the raw NTI logs, you find a hidden cost driver buried deep inside the data payload. This diagram shows the life of a single AI request. When you send a prompt, the reasoning model generates internal thinking tokens before producing an answer. Across 8 models tested, these invisible tokens accounted for over 80% of the total cost. It is the digital equivalent of hiring a contractor because they advertise a low hourly rate, only to find they silently billed you for millions of private brainstorming hours before they ever picked up a tool. To see how this works in practice, look at what happened when researchers gave 2 different models the exact same Amy competition math problem. The premium GPT 5.2 models solved the problem efficiently. It mapped out a logical path and reached the correct result using only 562 thinking tokens. But the budget-tier Gemini 3 Flash model struggled. It looped through its own logic and burned through over 11,000 thinking tokens to reach that exact same result. The math on that single query is stark. 562 tokens at the premium rate costs roughly a penny. 11,000 tokens at the budget rate costs nearly 4 cents. The cheap model cost 4.3 times more for the identical output. Budget models often have lower base intelligence. They compensate by thinking much harder and much less efficiently, which directly drives up the final bill. That 20x gap assumes a single query, but production AI workloads are sustained multi-turn conversations. This graph tracks the exponential cost of a user conversation. Every time a user replies, the model reprocesses all previous context, triggering new thinking chains. By the 8th turn, compounding context creates a 10.5x cost multiplier, turning a 50-cent interaction into a $5 charge. Because the pricing pages make compute look cheap, developers are using high reasoning models for simple, repetitive tasks. They are effectively paying for a high-performance engine just to run an errand down the street. There is a worse outcome than an inefficient bill, paying for millions of thinking tokens and receiving a wrong answer. In the Stanford study, Gemini 3 Flash burned through 208 million thinking tokens on a single benchmark and still produced incorrect results. When accuracy is the goal, the most relevant number on your bill is the cost per correct answer. A premium model with a higher rate but perfect accuracy is cheaper than a budget model that requires retries. Every wrong answer from a cheap model adds the cost of the initial failure, the automated retry, and the human verification needed to fix the error. Efficiency determines the final invoice. Because premium models reason with precision, they consume a fraction of the compute, making them the more economical choice in a production environment. To protect your budget, you have to stop estimating costs based on listed prices. Run at least 100 sample queries from your actual workload to find your real operational baseline. Next, set hard computational caps. Providers like Anthropic allow you to place strict limits on exactly how many thinking tokens a model can use per query. Other providers bury these controls deep in their documentation. Finally, do not wait for a monthly invoice. Monitor your cost per query in real time to catch specific anomalous loops before they drain your account. Choosing a model based on the lowest per token rate is no longer a viable budgeting strategy. For reasoning models, the pennies you save on the sticker price are routinely lost to invisible millions of thinking tokens.